Hello viewers, welcome back. So in this tutorial I am going to implement a multi-layer of neural network through custom model. So let's begin. Import TensorFlow, as TF, import NumPy as NP, import matplotlib.pyplot as plot. Now define some parameters. Okay, let's import the data, and as dataset I will be using patient dataset of MNIST. So train a y test, y train, x test, and y test. So tf dot keras dot datasets dot fashion MNIST load data. So let me show you the shape, and here you can see there are 60,000 images, and each of the image is 28 by 28. Okay, so I have to process the images. So let's do so. X train and X test. So I will be normalize the data. So X train dot divided by 255 0. Now X test divided by 255 0. Now X train X test, I want to cast them to a TensorFlow plot 32. So for that reason tf.cast and X train out there, and right out there tf.plot 32, and similarly for X test pass out there X test and tf.plot 32. Okay, now I want just compile this line. Now okay, X train X test, I want to reshape them since they are 2D array. Now I want to bring them to a single array. For this is tf dot reshape dot X train, keep the shape out there -1 and 784 -1 28 into 28 will do, or you can give 784 same. Now tf dot reshape, pass out their X test and pass out their shape -1 and 28 into 28. Okay, and another thing I can do here, I have loaded the data so I can show you the data, some of the data, so that you can have better intuition. So figure plot dot figure, pass out their shape, fixed shape equal to 8 by 8. So for I in range of, I will show you 25 image, then plot dot subplot, pass out there 5 comma 5 comma I plus 1 plot.imshow and pass out there the images. So let's see some of the image from xtrain I. Okay, that should do. Now come out of the log. Show. So just run this line of this cell. Okay, there will be error, so run from the first here. Okay, fine. Okay, there are error, so let me check. Fixed size. Okay, I give fixed shape, fixed size. Now run this line, and you can see this is my data set out there, and these are some of the images, some of the sample images which you can see. Now I will be making a multi-layer model, so just compile this line and also this line. Okay, done. Now I want to write the class name of each of the image, so class level out there. So this line of code, just run this line of code out there. Okay, fine. So I have images, and now I want to make the data set to training data and iterable. So for that reason I have to take help of train data. So TensorFlow slices. So tf dot data dot dataset, I'll make them from tensor. I'll make slices and pass out there xtrain and ytrain. Okay, fine. Now I want to randomize my data. So data dot equal to train data. I want to shuffle my data, so dot shuffle and pass out there 60,000. Okay, that should be fine. Now I want to make batch of my data, so for that reason data dot batch, so pass out there I will be making 100, each batch of shape 100. That should be fine. So write out there batch size. Okay, that should do. Now I want to make the variables of my weights. For that reason weights, I will be making a dictionary. So write out there h1 such that tf dot variable and pass out there tf dot random dot normal and give the shape out there. The input shape is 784. In the first layer I will be using, let's say, 128 euro. Okay, so h2, this is the second hidden layer. So tf dot variable and pass out there tf dot random dot normal and give the shape out there 128, and here I will be giving let's say 256 euro. Okay, so 128 come from here, so this is the 128, and here this is the number of neuron of this layer. So so there are 10 classes out there. So tf dot variable and tf dot random dot normal and give the shape out there 256 comma 10 for 10 neurons. Now I have to define the biases. bias is equal to, again make in another dictionary. So bias 1 such that tf dot variable, and give out there tf dot random normal, and give the shape out there of there are 128 neurons, so the bias shape will be 128. So in the b2 tf dot variable and give out there tf dot random dot normal, and there are 256 neurons, so give the shape 256. Now in the out I'll be giving tf dot variable and tf dot random dot normal, and there are 10 neurons, so I'll be giving 10. So I am using 3 layers: hidden layer 1, hidden layer 2, and the output. Okay, so I have used bias. So these are the variables which I need to train. So I can now create my model. So def dot model and pass out there x. Now layer 1 equal to tf dot matmul. Now pass out there x and hidden layer 1. So a weights, and I'll be giving the h1 layer over there. Okay, so here it will do matrix multiplication with x and with this layer. Okay, so now I want to add with the bias. So tf dot add. Now pass out this output and give out there bias. So bias is I'll be giving b1 out there. Okay, so boom. Now I want to pass this layer 1 to a activation function. So tf dot nn dot sigmoid and give out there layer 1. Okay, so this is the complete layer 1 out there with a activation function. Now I want to make the second layer. So tf dot similarly add tf dot matmul, pass out there layer 1 and give out there the weights of layer 2 and add this one with bias of layer 2. So b2 out there. Fine. Now I want to pass this layer to a activation function. So tf dot nn dot sigmoid and pass it to a layer 2 out here. Okay, fine. Now finally my output layer. So tf dot add tf dot matmul and pass out there layer 2 and give out there weights of layer 2. So weights of hidden that is output, and give the biases of output. Okay, fine. Now I have to return this output passing through a sigmoid function. So nn sigmoid and output. Fine. So my model is created. Now I want to define some compute loss. So it will calculate the loss. So give out there y and print, or you can write out there true y, and loss equal to tf dot keras dot losses dot sparse. Since I didn't make the data to a hard encoded, so I will use sparse categorical cross entropy. Categorical cross entropy. Fine. And password there true y. True y and the predicted y. Okay, fine. Now I want to return. So return return tf dot reduce sum. So I want to calculate the total loss of a single batch def. Okay, now def equal to compute accuracy. For accuracy calculation, again true y, pass out their predicted y, and I want to make the true y to hard encoded here. tf dot one hot and pass out there true y and give out that 10 since there are 10 classes. So accuracy equal to tf dot keras dot matrix dot categorical accuracy and pass out there true y and pass out there predict. So okay, ultimately I have to return tf dot reduce mean. So I have to mean the accuracy for 100 data since the batch size is 100. Okay, now I want to train my model. So yeah, I am left with defining my optimizer. So optimizer equal to tf dot optimizer dot atom and give out there learning rate equal to 0.001. okay, so since I am using sparse categorical cross entropy, so I have to use atom here. Now okay, done. Now it's time to train my model. For epoch in range, so I'll be using 10 epochs. Okay, now for step, and here is the batch x, batch of y in enumerate, pass out their train data. So this is what I defined surely. Okay, so train data out there. So in each iteration it will take 100 images and it will train the model, and it will go to the whole data set for 10 times since epoch is 10. Okay, so now I have to take help of tf dot gradient tab as step. Now prediction here equal to model, pass out their batch of x. Okay, so now I want to calculate the loss. For that reason, loss equal to, now I want to take help of compute loss function. So compute loss out there, now pass out there the true value, so batch of y for 100 data and predicted value. So this is the loss. Now I want to calculate the grades with respect to loss. For that reason, tab dot gradient and pass out their loss and pass out their list of weights dot numpy, sorry, values, and I want to sum this one list of again biases dot values. Okay, so fine. Now I got grades, that is gradient values. Now I want to optimize, so optimize equal to optimizer dot apply gradients and give out their zip the grade values and copy this line. So Ctrl C, after comma put out there. Okay, fine, I am done. Now I want to what should I show? Okay, now I want to calculate the accuracy equal to, now take compute accuracy and pass out there the true value for 100 data and the predicted value for 100 data, and now accuracy is done, loss is done. Now I can print some of the values. So it's right out there, step percent D will find, then accuracy percent 0.3F will find, then loss equal to again percent 0.3F. now percent right out there step and right out there accuracy dot numpy, since it's a tensor. Now pass out there loss dot numpy. Okay, since it's a tensor, so fine. So now let's train my model. So let's train. Hopefully I will not get any error. So model dot and weights is not defined. Let's see, where is my, okay, so there are some error out there, and you can see tf.random.normal out there, normal out. So invalid syntax. Okay, wait, okay, I didn't give out the comma, and similarly for here too I didn't give comma. Okay, hopefully it should work now, and the training has started out there, and you can see, so more I go downwards, my accuracy is increasing, and you can see accuracy is increasing, and the loss out there in the downwards direction will decrease. So let's see. Okay, so uh, okay, I'm done. So I got accuracy around 90% and loss is 21.116 for each of 100 data. Okay, fine. Now let's go for graphical prediction showing. See, and here I'll make prediction with the help of my model, equal to model, and pass out there x test. And what I want to do, okay, so it will have prediction error. Fine, I got prediction. Now I want to see my data here. Give out the test. Now here it will give a numpy. Let's bring the numpy value out there since it's a tensor, and I want to reshape this one. So reshape to 28 comma 28. Now everything is fine. Now let's give the level out there. So plot dot x level for each of the image, and here I'll be bring the class names. So class names, and here the index will be numpy dot argmax, and here prediction for ith element. Okay, now I want to convert this one to a numpy value, and I want to have the maximum of this argument. Okay, fine, everything is fine, look good. So plot dot xticks, keep that blank. Hopefully everything should fine. Let's see, and you can see this is my data out there, and here is the prediction. This is ankle boat out there, pullover shirt, pant, trouser, shirt, pant, trouser, coat, shirt, sandal, sorry, and sneaker. So this is all for this tutorial, and as always, thanks for watching.